In 1943, amid the throes of World War II, the city of Detroit pulsed with the rhythm of industry. Known as the Arsenal of Democracy, Detroit's automotive plants had been swiftly repurposed to produce military engines, tanks, and aircraft, supporting the Allied forces' efforts across the globe. It was here that a German engineer, once a technician in the Ruhr Valley, a region synonymous with industrial prowess, found himself navigating the sprawling landscape of American wartime production. The transformation of American factories was meticulously orchestrated, guided by directives from the War Department. Circulars from 1942 and 1943 outlined the necessary shifts in production, emphasizing efficiency and minimal disruption to existing workflows. In stark contrast to Germany's beleaguered factories, which were increasingly reliant on scavenging and repurposing, American industry demonstrated an uncanny ability to adapt. The German engineer arrived at one of Detroit's largest plants, its layout a testament to modern industrial design. The factory's capacity had been expanded to accommodate a 3-shift workflow, ensuring continuous production around the clock. Conveyor belts hummed with relentless precision, guiding components to their respective quality control stations. Each station was manned not just by seasoned workers, but also by newcomers, women and immigrants, trained to operate welding machines with exacting skill. The integration of diverse labor was well documented in the records of the U.S. Army Provost Marshal General. As the war effort intensified, labor shortages necessitated the inclusion of previously underrepresented groups in the workforce. The records reveal logistical details, the transportation of workers, their assignment to various sectors such as agriculture, canneries, and factories. In these wartime plants, the German engineer observed a workforce that was not only diverse but highly organized, each member contributing to the seamless flow of production. The engineering marvels of the American assembly line were not lost on the German visitor. In his homeland, factories struggled with resource scarcity and the constant threat of Allied bombing campaigns. Here, in contrast, a seemingly inexhaustible supply of materials fed into the production lines, facilitated by a robust logistics network that included railroads and transportation hubs. The role of prisoners of war and internees in supporting the American war effort was also significant. Red Cross inspections and camp newspapers from the period provide insight into the conditions and contributions of these laborers. At various camps, such as Camp Atterbury in Indiana, POWs were engaged in agricultural labor, canning, and even skilled factory work. These camps, while primarily focused on containment, also emphasized productivity, aligning with the broader national strategy of resource maximization. Camp Atterbury, one of the larger facilities, housed thousands of prisoners within a well-organized compound. Guarded by units trained to maintain order and discipline, the camp operated with an efficiency that mirrored the factories beyond its barbed wire fences. The prisoners' labor was compensated with wages in the form of coupons, redeemable for goods within the camp. Food systems were meticulously managed, with rations strictly adhering to national policies. Civilian attitudes towards these wartime changes varied. While many Americans embraced the economic boom and the opportunity to contribute to the war effort, isolated incidents of tension and resistance were recorded. Some civilians expressed unease at the presence of foreign laborers and prisoners, a sentiment documented in local newspapers and community reports. Within the factory, the American supervisor's casual explanation of the plant's wartime transition underscored a remarkable adaptability. Before the war, the plant produced cars. During the war, it manufactured engines, and after, it would return to civilian automotive production. This pragmatic approach highlighted an underlying truth. The United States had not so much mobilized its economy as it had redirected its existing capabilities. The well-being of workers, both American and foreign, was supported by comprehensive systems of medical care and education. YMCA programs offered recreational and educational opportunities, fostering a sense of community and morale among workers and internees alike. Mail services were maintained with efficiency, ensuring communication with families and the outside world. As the war drew to a close, the focus shifted to post-war repatriation and re-education programs. Directives from the War Department and Allied forces outlined the processes for returning prisoners to their homelands, alongside initiatives aimed at dismantling ideologies through structured educational programs. These efforts were part of a broader strategy to reshape the post-war world, reflecting the shifting geopolitical landscape. The German engineers' observations in Detroit offered a lens into the formidable industrial capabilities of the United States during World War II. In witnessing the seamless redirection of American industry, he recognized a formidable truth. Where Germany's factories were strained to the breaking point, America's had simply shifted gears, ready to resume their peacetime pursuits with the same precision and efficiency that had fueled the war effort. As the German engineer continued his exploration of the Detroit factory, he moved from the central assembly line towards the expansive storage bays. These bays, vast and meticulously organized, held an array of components and raw materials essential for maintaining the plant's relentless pace. Each section was clearly labeled, with materials stacked in uniform rows, awaiting their transformation into engines and other military necessities. The engineer noted the efficiency with which the supply chain was managed, an orchestra of logistics that ensured no idle moments along the production line. The storage bays were not merely gigantic warehouses filled with metal and components, they were the heartbeat of the factory. Every square foot was utilized with precision, reflecting a deep understanding of spatial management. Pallets of steel sheets, aluminum blocks, and barrels of oil lined the walls, while crates of smaller components were stacked neatly in the center. The air was filled with the distinct smell of metal and oil, a testament to the industrial prowess that defined the era. The engineer marveled at the seamlessness of the operation, noting how every item was cataloged with military precision, each barcoded and logged into a centralized system that tracked its journey from delivery to assembly. The plant's logistical prowess was further illustrated by the seamless integration of rail lines directly into its infrastructure. Train cars arrived with precise regularity, delivering steel, aluminum, and other critical inputs, while removing completed engines destined for military installations across the continent. The engineer observed the synchronization between the plant and the broader transportation network, a testament to the strategic planning underpinning the American war effort. The rail system was a marvel in its own right. Each train, a behemoth of steel and steam, was an integral part of the supply chain, its schedule meticulously planned to coincide with the plant's production cycles. The engineer watched as cranes and forklifts moved in choreographed harmony, unloading raw materials and loading finished products with a speed and efficiency that was almost mechanical. The tracks themselves were like arteries, pulsing with the lifeblood of industry, connecting the factory to a vast network that spanned the nation. This logistical integration was a stark contrast to the fragmented systems he was accustomed to back home in Germany, where resource scarcity and disrupted supply lines were common. Moving through the plant, he encountered numerous quality control stations, each overseen by workers with clipboards and calipers, diligently measuring and inspecting components for any deviations from specifications. These stations were not mere formalities. They represented a commitment to consistency and reliability in manufacturing. The engineer recognized this as a stark contrast to the conditions in Germany, where resource scarcity often led to compromises in quality and safety. The quality control areas were abuzz with activity, each station a hub of precision and scrutiny. Workers, clad in the traditional blue overalls, moved with purpose, their eyes scanning for any imperfections that could hinder the performance of the final product. The engineer noted the various tools and instruments at their disposal, from micrometers to gauges, each used to ensure that every component met the stringent standards set by the factory. The atmosphere was one of focused intensity, a reflection of the broader American ethos of excellence. He realized that this dedication to quality was not merely about meeting quotas. It was an embodiment of a deeper cultural value placed on reliability and trust. The engineer's attention was drawn to the welding stations, where a diverse workforce, including women and immigrants, expertly operated the machinery. Their proficiency with the equipment was evident, and he noted the training that must have been required to achieve such competence. The use of standardized procedures and documented workflows ensured that even those new to industrial work could quickly become productive members of the team. At the welding stations, sparks flew like tiny fireworks, illuminating the faces of the workers who operated the machines with deft precision. The engineer was struck by the diversity of the workforce, a tapestry of backgrounds and experiences united by a common purpose. Women, many of whom had never worked in factories before the war, stood side by side with immigrants who had come to America in search of opportunity. Each worker was a testament to the power of inclusivity and the ability to harness the potential of every individual. The standardized procedures were a masterstroke of industrial engineering, ensuring that even the newest recruits could contribute effectively. The engineer was impressed by the training programs in place, which not only equipped workers with technical skills, but also instilled a sense of pride and ownership in their work. Beyond the plant floor, the engineer observed the integration of prisoner of war labor at nearby Camp Atterbury. These POWs, primarily German soldiers, were employed in non-combatant roles that supported the broader war economy. The systematic approach to utilizing this labor force reflected the American emphasis on maximizing available resources. The engineer understood the irony of the situation, his compatriots contributing, however indirectly, to the very machinery that opposed them. The use of prisoner of war labor was a complex and sensitive subject. The engineer approached this area with a mixture of curiosity and apprehension, aware of the ethical and moral implications. At Camp Atterbury, the POWs worked under the watchful eyes of military personnel, their roles carefully delineated to avoid direct involvement in combat-related production. The engineer observed the camp's routine, noting the orderly conduct and the efforts to ensure humane treatment. The POWs, though far from home and in an unfamiliar land, seemed to have adapted to their circumstances, a testament to human resilience. The engineer pondered the broader implications of this practice, recognizing both its pragmatism and its potential for fostering a future reconciliation. The plant's adaptation to wartime production extended beyond its physical operations to encompass the societal structures that supported it. The local community, once reliant on the automotive industry, had pivoted to accommodate the needs of the war effort. Housing developments had sprung up to accommodate the influx of workers, and transportation systems were expanded to ensure that labor could be efficiently routed to where it was most needed. The engineer viewed these developments as a reflection of a society fully aligned with its industrial objectives, a unity of purpose that seemed absent in his homeland. The transformation of the local community was nothing short of remarkable. New housing developments, constructed with speed and efficiency, dotted the landscape, providing homes for the influx of workers who had migrated from all corners of the nation. Schools and hospitals were expanded to cater to the growing population, while public transportation systems were overhauled to ensure that workers could commute easily to the factory. The engineer noted the sense of camaraderie and shared purpose that permeated the community, a stark contrast to the fragmented and beleaguered towns he had left behind. This unity of purpose, he realized, was a powerful force, driving both the war effort and the broader social fabric. As he continued his observations, the engineer noted the plant's ability to anticipate and prepare for post-war transitions. The supervisor's earlier remarks about returning to car production underscored a foresight in planning that extended beyond immediate needs. This adaptability was evident in the dual-purpose design of the machinery and facilities, which could be repurposed with minimal disruption. It was a manifestation of the American industrial ethos, flexibility and foresight as cornerstones of resilience. The engineer marveled at the foresight displayed by the factory's leadership. While the plant was currently focused on producing military engines, there was a clear vision for the future, a future that would inevitably shift back towards consumer goods. The machinery, while currently configured for wartime production, was designed to be easily retooled for peacetime manufacturing. This dual-purpose design was a stroke of genius, allowing for a seamless transition once the war ended. The engineer realized that this adaptability was not merely a technical feat, it was a strategic advantage, ensuring that the factory would remain viable and competitive in the post-war economy. In reviewing factory records, the engineer found detailed accounts of workforce management, including initiatives for skill development and employee welfare. Programs for worker training were not limited to technical skills, but encompassed broader educational opportunities, preparing the workforce for peacetime industries. The emphasis on human capital development was in sharp contrast to the German focus on sheer production output, often at the expense of worker welfare. The factory's commitment to its workforce was evident in the meticulous records the engineer examined. Training programs were comprehensive, covering not only the technical aspects of machinery operation, but also broader educational pursuits. Workers were encouraged to pursue courses in management, engineering, and other disciplines, preparing them for a future beyond the confines of the factory floor. The engineer was impressed by the holistic approach to workforce development, recognizing that this investment in human capital was a cornerstone of long-term success. It was a stark contrast to the German approach, where the relentless drive for output often overshadowed the well-being of the workers. The engineer's inspection concluded with a visit to the plant's administrative offices, where the operations were meticulously documented. Charts and graphs lined the walls, illustrating production targets, efficiency metrics, and resource allocations. These visual aids provided a clear snapshot of the plant's performance, reinforcing the data-driven approach that underpinned American industrial success. The administrative offices were a hub of analytical activity, where data and metrics were the lingua franca. The engineer was struck by the array of charts and graphs that adorned the walls, each one telling a story of efficiency, output, and resource management. The precision of the documentation was impressive, providing a clear and accessible overview of the plant's operations. Every decision was informed by data, every strategy aligned with measurable outcomes. The engineer recognized that this data-driven approach was a key differentiator, enabling the factory to optimize its operations and maximize its output. In reflecting on his experiences at the Detroit factory, the engineer recognized the underlying principles that differentiated American and German wartime production. The American model of industry was characterized by strategic resource management, inclusive labor practices, and a commitment to quality and adaptability. These attributes, coupled with an integrated logistical framework, enabled the United States to sustain a formidable industrial output without resorting to the desperate measures seen in Germany. The engineer left the factory with a profound understanding of the mechanisms that powered the American war effort. This understanding, however, was not merely academic. It carried with it a realization of the broader implications for the conflict and the post-war world. The efficient redirection of American industry, rather than a full-scale mobilization, revealed an untapped potential that could be harnessed for reconstruction and peace. As he prepared to return to Germany, the engineer pondered the future of his own nation's industries. The lessons learned in Detroit would remain with him, shaping his perspective on the possibilities that lay ahead. In the face of inevitable change, he recognized the need for a new approach, one that embraced adaptability and foresight, much like the American example he had witnessed. The engineer's journey through the Detroit factory provided him with more than an understanding of American industrial capabilities. It offered a vision of what could be achieved when industry and society worked in concert towards a common goal. This vision, rooted in the practical reality of the plant's operations, would inform his contributions to Germany's post-war recovery, laying the groundwork for a future shaped by the lessons of the past. As he boarded the train that would begin his journey home, he carried with him a renewed sense of purpose and a belief in the power of industry to forge a better future. As the German engineer completed his tour of the sprawling Detroit factory, he was led through a maze of bustling activity, eventually finding himself at the threshold of a nearby logistics hub. This facility, which until recently had been a distribution center for automotive parts, had undergone a radical transformation. It was now reconfigured to orchestrate the complex flow of military components across the Midwest, serving as a crucial logistical artery for the war effort. Inside, the cavernous space was filled with rows upon rows of inventory, each shelf meticulously labeled and cataloged, a testament to the precision that characterized this operation. The air was filled with the rhythmic hum of machinery and the distant clatter of conveyor belts, each one a vital part of an intricate system designed for the rapid movement of crates. These crates, stamped with military insignia, were destined for various installations and production sites across the country. As he watched, the engineer couldn't help but be impressed by the efficiency with which the facility operated. It was a well-oiled machine, each component playing its part in a larger, perfectly synchronized symphony. The logistics manager, a middle-aged man with an air of practiced efficiency and the confident demeanor of someone who had spent years in the industry, guided the engineer through the facility. He explained in detail how the center operated in conjunction with the nation's extensive rail networks. The hub was a critical node in a vast web that linked raw materials, production facilities, and final assembly plants. Rail cars arrived with clockwork regularity, each one laden with steel, aluminum, and other essential resources. The contents of these rail cars were swiftly unloaded and redistributed with a speed and precision that ensured uninterrupted production on the assembly lines. This scene stood in stark contrast to the engineer's experiences back in Germany, where transportation networks had become increasingly vulnerable to Allied bombing campaigns. These disruptions severely hindered the flow of resources, forcing factories to scrounge and improvise just to keep their operations running. In the United States, however, such logistical precision ensured that every cog in the industrial machine functioned without impediment, a testament to the strategic foresight that underpinned the American war effort. The engineer's next destination was an adjacent training facility where new workers were being rapidly educated in the skills necessary for wartime production. The facility, once a technical college, had been repurposed to accommodate the influx of labor required to meet the demands of the war. Here, men and women alike were instructed in the operation of complex machinery, the nuances of quality control techniques, and the vital safety protocols that would keep them safe in their new roles. The curriculum was streamlined yet comprehensive, designed to transform novices into proficient operators in a matter of weeks. Classrooms buzzed with activity, the hum of instructional films mixing with the clatter of typewriters. Instructors, many of whom had been industry professionals before the war, imparted their knowledge with precision and a palpable sense of urgency. The engineer noted the diverse backgrounds of the trainees, a reflection of the inclusive recruitment practices that characterized the American workforce. Immigrants, rural migrants, and local residents all contributed to the labor pool, their collective efforts harnessed through a systematized approach to training and integration. The adaptability of the American workforce was further exemplified by the presence of German POWs, who were employed in non-combat roles across various sectors. At places like Camp Atterbury, these individuals were integrated into the labor force under strict supervision, providing additional manpower for essential tasks. This strategic use of POW labor highlighted the pragmatic approach adopted by the United States, ensuring that every available resource was utilized to sustain production levels. The engineer was struck by the seamless coordination between civilian and military sectors. Government agencies, in collaboration with private industry, orchestrated the allocation of resources and labor with remarkable efficiency. This partnership ensured that production targets were met and often exceeded, reinforcing the industrial might that underpinned the Allied war effort. As the tour concluded, the engineer was escorted back to his temporary accommodations, where he had the opportunity to immerse himself in a wealth of technical documents and production reports. These records offered further insight into the operational methodologies employed by American factories. Detailed schematics outlined the modifications made to existing automotive assembly lines, allowing them to accommodate the production of aircraft engines, artillery components, and other military hardware. Despite the complexity of these changes, the underlying principles of efficiency and standardization remained constant. The engineer marveled at the ingenuity displayed in adapting civilian manufacturing techniques to military applications. Each modification was meticulously documented, ensuring that post-war reconversion could be accomplished with minimal disruption. In the evenings, the engineer attended community meetings where local leaders discussed the broader impacts of the war on Detroit's economy and society. These gatherings, held in converted school auditoriums and community centers, provided a forum for residents to voice their concerns and aspirations. The discussions often centered on the anticipated post-war transition, with many expressing optimism about the prospects for continued economic growth and technological innovation. The engineer observed that these community interactions were emblematic of a broader societal mobilization, where a collective effort and shared purpose drove the war effort forward. The spirit of cooperation extended beyond the factory floor, permeating every aspect of American life. This unity, he realized, was a potent force, one that contrasted starkly with the factionalism and resource scarcity that plagued Germany. As the days progressed, the engineer's understanding of American industrial capabilities deepened. He meticulously documented his observations, compiling a comprehensive report that would be sent back to his superiors in Germany. The report highlighted the key elements of American success: the integration of civilian and military sectors, the adaptability of the workforce, the strategic use of resources, and the effective coordination of logistics. In his analysis, the engineer acknowledged the formidable challenges facing Germany. The nation's factories, increasingly isolated by the Allied blockade and relentless aerial bombardment, struggled to maintain output. The lack of raw materials and skilled labor compounded these difficulties, leading to a reliance on improvisation and salvage operations. In contrast, the United States, with its vast resources and unscathed infrastructure, had the luxury of planning and executing a coherent strategy. The engineer's report concluded with a series of recommendations for post-war Germany. He emphasized the need for a comprehensive reconstruction plan that prioritized industrial efficiency and workforce training. Drawing on his experiences in Detroit, he advocated for the establishment of centralized logistics hubs and training facilities to facilitate rapid industrial recovery. His insights, born of first-hand observation, offered a blueprint for rebuilding a shattered economy. As his assignment in Detroit drew to a close, the engineer reflected on the lessons he had learned. The American industrial model, with its emphasis on flexibility, inclusivity, and strategic foresight, was a powerful testament to the nation's ingenuity and resilience. Despite the devastation wrought by war, the engineer harbored a cautious optimism that these principles could be adapted to guide Germany's future. The engineer departed Detroit with a newfound appreciation for the complexities of wartime production. His journey had provided a unique perspective on the mechanisms of American industry, revealing the intricate interplay between technology, workforce, and logistics. As he boarded the train that would take him to his next destination, he carried with him the knowledge that these insights could play a critical role in shaping the post-war world, a world where the lessons of the past could help forge a more stable and prosperous future for his homeland. The German engineer's observations continued as he moved deeper into the labyrinthine corridors of the Detroit plant. The rhythmic pulse of the machines accompanied his steps, an industrial symphony that underscored the plant's operational tempo. Each section of the factory revealed another facet of American industrial prowess, meticulously orchestrated to support the war effort. The assembly line, a marvel of modern engineering, functioned with clockwork precision. The engineer was acutely aware of the synchronized movements of conveyors as they transported engine components with unwavering regularity. Each station along the line was manned by workers whose expertise was evident in their fluid, practiced motions. The engineer observed the seamless integration of diverse laborers, including women and immigrants, who operated welding machines and other equipment with a level of skill that defied his initial expectations. The sight of women, often referred to as Rosie the Riveters, confidently handling heavy machinery, was both surprising and enlightening. In Germany, the war had also mobilized women into the workforce, but the American approach appeared more integrated, with women playing vital roles in every aspect of production. Their determination and skill were palpable as they worked alongside their male counterparts, contributing significantly to the war effort. The engineer realized that this inclusivity not only bolstered production, but also fostered a sense of unity and shared purpose. As he proceeded, the engineer encountered a section dedicated to quality control. Here, inspectors scrutinized components with rigorous attention to detail. Gauges and measuring instruments were employed with precision to ensure that each product met the stringent standards set forth by the government contracts. The engineer recognized this as a stark contrast to the German factories, where resource scarcity often necessitated compromises in quality. The meticulous nature of the quality control process was a testament to the American commitment to excellence, reflecting a broader cultural ethos that valued precision and reliability. The plant's efficiency was further exemplified by its tool control systems. Each tool was cataloged, tracked, and maintained in optimal condition. A system of checks and balances ensured that tools were returned to their designated locations after use, minimizing loss and maximizing productivity. The engineer acknowledged the strategic foresight in this approach, which contrasted sharply with the often haphazard tool management he had witnessed in the Ruhr Valley. This meticulous organization of resources was indicative of a broader American strategy that sought to eliminate waste and enhance efficiency at every turn. The American supervisor, a veteran of the automotive industry, provided the engineer with insights into the plant's operations. He explained how the factory had been repurposed from civilian automotive production to military manufacturing with minimal disruption. This adaptability, he noted, was a hallmark of American industry, a testament to its ability to pivot swiftly in response to national needs. The supervisor's pragmatic demeanor reflected the broader ethos of American industrial leaders who approached wartime production with a focus on efficiency and innovation. The engineer was struck by the supervisor's willingness to share knowledge and collaborate, a refreshing departure from the more guarded and insular practices he had encountered back home. The engineer's tour extended to the facility's logistics and supply chain operations. Here, the coordination of raw materials and finished products was a marvel of organization. Rail spurs connected the plant to a vast network, facilitating the seamless transport of goods to and from the facility. The engineer observed the meticulous handling of resources, a stark contrast to the chaotic conditions back in Germany, where logistical challenges often impeded production. The integration of transportation infrastructure with production processes exemplified a holistic approach to industrial operations, ensuring that each component of the system functioned in harmony. The plant's adaptability was further underscored by its workforce development programs. Training facilities within the plant ensured that new workers could quickly acquire the skills necessary for their roles. The engineer noted the integration of educational initiatives, which not only improved individual proficiency, but also contributed to the overall efficiency of the operation. The plant's investment in its workforce was evident, a strategic decision that paid dividends in productivity and morale. The engineer was particularly impressed by the focus on continuous improvement and the encouragement of innovation at all levels, fostering an environment where employees felt empowered to contribute ideas and drive progress. The integration of prisoners of war, POWs, from Camp Atterbury into non-combatant roles within the plant highlighted another dimension of American resourcefulness. These individuals, under careful supervision, contributed to the labor force, performing tasks that freed skilled workers for more specialized roles. The engineer recognized this as a pragmatic solution to labor shortages, further demonstrating the American ability to leverage available resources effectively. The humane treatment and purposeful employment of POWs were in stark contrast to some of the harsher practices he had witnessed elsewhere, reflecting an underlying respect for human dignity even amidst the exigencies of war. The societal infrastructure surrounding the plant also played a crucial role in supporting its operations. Housing developments for workers and expanded transportation systems facilitated the daily influx and egress of personnel. The engineer noted the strategic placement of these facilities, which minimized travel times and maximized productivity. This holistic approach to industrial support was another contrast to the fragmented and often inadequate infrastructure he had encountered in Germany. The engineer marveled at the foresight and planning that had gone into creating an ecosystem that supported not just production, but also the well-being of the workforce. As the engineer concluded his tour, he reflected on the broader implications of the American model. The plant's emphasis on flexibility, inclusivity, and strategic foresight represented a blueprint for industrial efficiency that could be adapted to post-war reconstruction efforts. The engineer acknowledged the potential for these insights to influence Germany's future strategies, recognizing the need for a paradigm shift in industrial practices. The experience had opened his eyes to the possibilities of a more collaborative and innovative approach to industry, one that prioritized adaptability and embraced diversity as a strength. The engineer's visit to the Detroit plant provided a comprehensive understanding of the American approach to wartime production. The efficient use of resources, the adaptability of the workforce, and the strategic integration of logistical and societal support systems all contributed to a formidable industrial effort. As he departed, the engineer carried with him a wealth of knowledge that could inform future endeavors, underscoring the transformative power of industry in shaping a nation's destiny. In the following weeks, the engineer's observations were compiled into a detailed report intended for dissemination among German industrial leaders. The document outlined the key elements of the American approach, emphasizing the importance of adaptability, workforce development, and logistical coordination. The report also highlighted the strategic integration of diverse labor sources and the critical role of societal infrastructure in supporting industrial efforts. The reception of the report among German officials was mixed. Some viewed it as a valuable resource, offering insights that could aid in post-war reconstruction. Others, however, were skeptical, viewing the American model as an unattainable ideal given Germany's current circumstances. Nevertheless, the report served as a catalyst for discussions on the future of German industry, sparking debates on the need for reform and innovation. The engineer remained hopeful that the seeds of change had been planted and that a new era of industrial progress was within reach. The engineer continued his work in Detroit, liaising with American counterparts and exploring further opportunities for collaboration. His experiences in the United States provided him with a unique perspective on the potential for industrial transformation. As the war progressed, the engineer remained committed to the idea that the lessons learned from the American model could contribute to a brighter future for his homeland. He envisioned a future where German industry could embrace similar principles of adaptability, inclusivity, and strategic foresight, paving the way for a more resilient and prosperous nation. The story of the German engineer's journey through the Detroit factory is a testament to the power of observation and the potential for cross-cultural exchange in the realm of industrial innovation. The insights gained from his experiences in America offered a glimpse into a future where adaptability, inclusivity, and strategic foresight could drive progress and prosperity even in the face of adversity. As he reflected on his journey, the engineer felt a renewed sense of purpose and determination, eager to contribute to the rebuilding of his homeland with the knowledge and insights he had gained. The German engineer's comprehensive exploration of Detroit's wartime production capabilities ultimately concluded with a synthesis of the themes and insights he had gathered throughout his visit. As the war drew closer to its end, the engineer's focus shifted to the application of these observations to the impending post-war reality faced by his homeland. Returning to Germany, the engineer faced a nation in disarray, its industrial base severely damaged and its workforce depleted. However, armed with a detailed report and a strategic vision inspired by his American experience, he began advocating for a reconstruction strategy that embraced the principles of adaptability and inclusivity. His proposals emphasized the establishment of centralized logistics hubs, similar to those he had seen in Detroit, to streamline resource distribution and production processes. The engineer's advocacy extended to the reformation of workforce training programs, highlighting the importance of integrating diverse labor groups and providing comprehensive educational opportunities. He argued that such inclusivity would not only bridge the labor gap, but also foster a more innovative and resilient industrial sector. His recommendations for quality control and tool management systems were also rooted in the meticulous practices he had observed, aiming to improve efficiency and reduce waste across German factories. In the broader context of post-war Europe, the engineer's insights contributed to the dialogues on industrial collaboration and technological exchange. His experience underscored the value of strategic partnerships and shared knowledge in rebuilding economies devastated by conflict. As Germany embarked on its path to recovery, the principles gleaned from the American model became instrumental in shaping a new era of industrialization. The engineer's work played a modest yet significant role in the gradual revitalization of Germany's industrial landscape. Through persistent efforts, he and like-minded leaders laid the groundwork for a future defined by cooperation and sustainable growth. His journey through the Detroit factory became a cornerstone of his legacy, symbolizing the potential for transformation through understanding and adaptation. Reflecting on his experiences, the engineer recognized the enduring impact of his observations in Detroit. The insights he gained not only informed Germany's industrial recovery, but also influenced the broader narrative of post-war reconstruction. In the years that followed, he remained a proponent of innovation and adaptability, advocating for continuous improvement and the embrace of new ideas as essential components of progress. The German engineer's journey concluded not with a single decisive transformation, but with a series of incremental changes that gradually reshaped the industrial and economic landscape of his homeland. His legacy, grounded in the lessons of wartime efficiency and adaptability, continued to inspire future generations, serving as a reminder of the power of resilience and the potential for renewal in the aftermath of conflict.